Good afternoon. Can you hear me?
Yes.
Okay, so you should now also see my presentation in full screen mode, right?
Yes.
Okay, thank you. So my name is Dirk Tiede. With me is Martin Soetmans. We are both from the University of Salzburg, and at the same time we are part of a spin-off company here at the university called Spatial Services. The idea of the spin-off company is to bring our research results into the market. And this is one of these applications we have done in the last years that called SIAM as a service. So we bring a proven software as a cloud service to the market for everyone. You see that there's also another name involved in the slide called Color 33. This endeavor was an ESA incubed activity. So we got co-funding from ESA to develop such a service, and during that activity a rebranding started to make that more appealing for the customers. So if we say SIAM as a service and later Color 33, that's the same but with a rebranding. Let me just start with this. So we are back on Earth observation, not in the satellite domain anymore. So we are using the images. Every one of us has the problem to bring the data into information. What you see in the background is a conversion of raw data into spectral categories. This is a software we are using for several years here. It's called, let me go to the next slide, SIAM Satellite Image Automatic Mapper. It has been originally developed by our Italian colleague Andrea Baraldi, who is also or was involved in the project team, and we worked together for several years now, even more than a decade. That software is a fully automated, parameter-free, training sample-free software which does a spectral categorization of remote sensing data on a pixel-based manner. It works in near real time. So in the software version, we need still 5 minutes maybe per Sentinel-2 image, but it has linear complexity. It can be parallelized. Martin will later tell you how much time that needs if we have brought that to the cloud. It has a multi-sensor support. So in principle, every remote sensing data set, multispectral, at least 4 bands, RGB and near infrared, but also shortwave infrared is addressed, can be used with that software package. The only need is that the data should be calibrated to at least top of atmosphere reflectance. So it's not like an unsupervised clustering routine and also not a deep learning approach. So we don't need samples. It's a physical model which uses the spectral categories and the spectral signature of the different bands to do the spectral categorizations. These categories have different granularities. There are 1833 up to 96. They are hierarchically clustered. We are focusing on 33 categories because they are cross-sensor categories. We developed that service for Sentinel-2, but it can in principle be extended to Landsat data, but also to very high resolution data where we have only 4 spectral bands, and 33 spectral categories can be derived from every of these sensors in any case. So we can do also a cross-sensor approach in here in the future. We use in our research group at the university these categories for years now. What we are working on is a semantic data cube approach, where we, in difference to classical data cubes, use not only the raw data, but we use these categories, and we can do analysis based on these semantic categories through time with these approaches. You will find here a reference to the implementation we did for the whole of Austria, for example, and there's also a website where you can look that up. So that's how we used that. But we had the idea that we bring that to the cloud for everyone. So you see here on that slide that every data set can be spectrally categorized. Yeah? Also the cloudy ones, and if we have that, we can address the clouds with the semantic categories, we can get rid of that, but we can still use parts of an image where clouds are not happening. So every data set can be analyzed, and the idea is to bring that to the cloud, or that's what we did, what we present here, to bring that to the cloud for everyone. Rebranding took place during the activity, so we call the service Color 33. Martin will tell you more about that later. How does that work? What was our motivation here? Sorry. So initially it's called Satellite Image Automatic Mapper as a Service. Motivation: bring the proven software to the market in the cloud, automatically convert any, in that case, Sentinel-2 data to information, support trustworthy and reliable workflows. Since it's a physical model-based approach, it's repeatable. It gives you always the same categorization for the same image. You know what is behind that. The method is an automated spectral categorization. We want to make it cloud-based, easy to use system. We want to make it scalable, so it's parallelized. We can parallelize that. We can make that really fast. We want to create also user interfaces with low thresholds, so for non-experts, and also some API or command line interfaces for integration into existing workflows. Main assets: reduce data preparation, create initial spectral building blocks for analysis. So these spectral categories are inferior to land cover. That's not a perfect land cover, it's below. So we, for example, derive different vegetation intensity categories, different water categories like deep water, turbid water, and so on. So the spectral categorization is fully automated, but it's not yet land cover. So on top, you can do that, and these are the initial building blocks where we can work with. So Earth observation information also for non-EO experts, establish reproducible and transferable basis for further interpretation. The idea was also to keep that lightweight, so it's a smaller project. What we did in here, so in times of money and co-funding and also time, but very much focused on this thing. For the idea, we got also a Copernicus Masters Prize here in Austria in 2020, and that helped us in also getting that InCube project funded by ESA. The user benefit is, to repeat that, there's no need for samples. It works worldwide on every scene. So it's not limited to any geographic area. You don't need EO expert knowledge to run that. Yeah? So there are no free parameters for you. And it's on cloud services, so you don't need your own hardware on that. Since it's based on a physical model, it's reproducible, so we can trust the results. It's completely repeatable, consistency for time series analysis, robust, and reliable. The competitive edge was there is at the moment no existing automated operational service that converts all Sentinel-2 data into a similar classification granularity. The future will bring that at some day. We see all the foundation models heavily trained on big GPU clusters and so on. At some day that will come, but nevertheless, we have here a sort of a reliable AI. We know what is behind that. It's a knowledge-based expert system, and that can be a building block for additional services. On the long run, we will also extend that to other data sets. As mentioned, we need at least top of atmosphere reflectance. That can be Sentinel-3, that can be Landsat, AVHRR, that can be also very high resolution data like Worldview, Pleiad, Planet, or anything else. Now I will hand over to Martin. That is what is the result of that endeavor, and he will explain that in more detail.
Looking at the state of the Color 33 services today, what's the offering here? You can access the service and therefore also the algorithm in a scalable way through cloud-based service, either through a graphical user interface or an API if you want to have a repeated analysis or if you want to scale the analysis. So every image can be produced on semantically enriched on demand. So there is no need for scheduling or these type of things. You just select the images you want to have, and then the service automatically produces them for you for the time and the area that you select. As Dirk mentioned in the beginning, we managed to get the algorithm also a bit faster running in the cloud. So we have about 2 minutes per Sentinel-2 granule. It always depends if, for example, there are some reprojections required and so on. But in general, that's our target. It's very scalable, so we can linearly scale with the amount of resources through this implementation. And it is worldwide applicable, so that means for whatever area where there are Sentinel-2 images, you can use that. So how to use that? That's considered a building block for workflows. So while it is nice to, let's say, look at the images as well, it has this probably a bit more like this 8-bit graphics from old computer games. But of course, you can actually do quite interesting and important things with it. Some of them are mentioned here, so you can do a very easy bitemporal change detection. So you just check which categories switched into which categories to identify loss of vegetation or flooding or these type of things. You can also observe the categories over time, for example, the occurrence, so how often a category occurred. I consider this is also one of the main advantages compared to non-semantic analysis, so analysis which are not based on categories. You can ask different questions. Pretty much you can do the same things, but in addition to that, you can ask questions of how often, how long, when was the first time, when was the last time, how large, and these type of questions, which you can only ask if you have categories that you can count. If you want to observe how long a flood was there, you need to have the categories that tell you whether this is water or not. Okay, you can also turn it around. So when you have the spectral reflectance and you have the algorithm, you can also use the algorithm to validate the reflectance, because if it doesn't identify the spectral signature, it will throw an error, and in this way you can identify some errors or spectral signatures that are not plausible. For example, if you want to do vegetation analysis, you can still calculate a vegetation index, but for example, you could stratify it to the areas which are identified as vegetation, and then you don't have to deal with cloud cover or areas which are, well, in general, not vegetation. For those areas, the vegetation index would not be calculated. It gives you a more targeted, more sharper analysis in this case. Okay, in general, you can use this for any type of analysis. It's completely open, whether it's deforestation, agriculture, natural disasters, and so on. On the left side, you see a very tiny time series where even visually you can identify the agricultural years, and putting this into an algorithm is equally very simple. You just deal with the categories. If category X switches to category Y and then to Z, then this should be considered a certain land cover change, for example. And this is very easy to formulate as a structure, as a program. but also very easy to explain to customers or to clients how this works. On the next slide, we see the different user and target groups, which potentially you are in as well, but this is a more general slide. So for example, if you are an app developer and you want to create a service or product yourself, there's an API. We have a reliable and scalable service behind that, powered by the cloud. It is a European cloud system, so it's not based on Amazon or Google. It's everything is in Europe, so also very stable from this perspective. From the research side, for research and education, we offer a lot of discounts as well. So as a scientist, the advantage here is you don't have to maintain your own system. The algorithm is scientifically validated. We are scientists ourselves. We produce papers. They are peer-reviewed. The algorithm, the process, everything is peer-reviewed and validated. And if you are from a domain that's not Earth observation, you can use the categories in a very simple way, directly apply your domain knowledge and don't have to deal with the very complex Earth observation pre-processing steps. And of course, if you're a student, you can immediately start with that. There is no waiting time, or you don't have to first get familiar with Earth observation. You can directly use the output. What we also offer is, if you don't even want to deal with any of this, that we offer directly added value services to deliver the information instead of the semantic enrichment. But of course, this would be done in collaboration with spatial services in different ways. One way how to do this is the ESA network of resources, which is on the slide here, which gives you an option to try it out without any costs or any risks. You get an introduction from us and some credits to use the service and to get familiar with it. So this is a very lightweight way of getting familiar and to learn more about the service. That's all from our side, and be happy to answer questions during the panel discussion. Thank you very much.